a truss problem using ANSYS software. Okay, so go to search bar, click mechanical APDL and open the mechanical APDL. The first step is go to file and change title. Go to file and change title. You can write a truss here. Click OK. You can go to plot and click replot, or you can go to fit view option. After clicking on fit view, the title is displayed on the lower left corner. This is an indication of we are going to solve a truss problem. Okay. Now, next, click on preferences. Click on preferences. Once again, in the truss question, we have to measure the displacement. Since we are measuring the displacement, it is going to be a structural problem. So, on the preferences, select the structural option. Click OK. So, ANSYS has 3 steps: preprocessor, processor and post-processor. So, first go to preprocessor. On element type, click on add, edit, delete. Again, click on add. Select the element type as link 3D finite strain 180 element for the truss problem. Okay, select link 180 element for the truss problem. Okay. Okay, click on close. Now, next, this element has no real constants, so no need to click the real constants, and select the material properties icon. On the material properties, click on material models, select structural, linear, elastic, isotropic and give the Young's modulus in the EX option. The Young's modulus is given as 70 into 10 cube Newton per mm square. In the question, it was given as 70 GPa. The units are mm square area and the units are in mm for length. So, to maintain the uniform units in the entire question, convert this 70 GPa into Newton per mm square, which means it is equal to 70 into 10 cube. Enter the value 70 into 10 cube here. Okay. Now, PRXY stands for Poisson's ratio. For the truss problem, it is not necessary to enter the value. Even though if you have entered the value, the effect is nullified. So, no need to give the Poisson's ratio. Okay, click OK. It is giving a error message that if you have not entered the value of Poisson's ratio, it will be set to 0.0. But I mentioned in the earlier, there is no importance to Poisson's ratio in the calculation of displacements in truss problem. So, click OK. Now, the next step is sections. Go to link. As we have added the link element type, so go to link, click add. The section ID is, let us say, 1. For this, enter the area. In the question, the area is given as 200 mm square. So, enter the 200 value here. Click OK. Okay. Now, click on modeling, create key points in active coordinate system. Let us starting with the key point number 1. What are the coordinates of the key point? Since it is the first point, I am treating as 0, 0, 0. So enter the value 0, 0 and 0. Even two zeros are also enough. Okay. So click OK. Now again go to key points in active coordinate system. Enter the key point number as 2. The second node or the second key point, the coordinates are along the x direction, the value is minus 500. So enter the value as minus 500. You can click on OK or you can click on apply, as we have third key point as well. The coordinates of third key point is along the x direction it is 400, along the y direction on the downward side the value is minus 300. So enter the values as along the x direction it is 400, along the y direction it is minus 300. Click OK. Okay, so 400 minus 300. Now after creating the key points, join these with lines. So go to lines, straight line between this and this, and also between this and this. Click on OK. Okay. So in modeling, we are trying to reproduce the same figure on the graphical user interface. And also we input all the parameters. We have given the Young's modulus value, the area value, and the coordinates are entered in the key point sections and they are connected by the lines. That means the geometry of the entire figure was completed. The next step is to convert this geometry into finite element model, for which go to meshing, click on size controls, go to manual size, enter lines, all lines, type 1 as the number of element divisions. Type 1 as the number of element divisions. That means for this element the entire properties are 1. This is converted as a single element. This also converted as the single element. Okay. Now based on the given option, that is number of divisions, the total structure is discretized. Okay. Now go to mesh, select lines and click pick all, because all lines to be meshed. You can select this and this, click OK, or also you can select the pick all option here, click OK. Okay. So the main purpose of meshing is to convert the geometrical model into finite element model. So I would like to know the element numbers. So go to plot controls, numbering, select the node numbers and also element numbers. Click OK. So this is the first element and this is the second element. The node numbers are 1, 2, 3. With this, the preprocessor step is completed. Now go to solution, analysis type, new analysis, static analysis and define loads. Apply structural displacement. In the question, the node number 3 and node number 3 along with the node number 2 are fixed, which means there is no displacement at node number 2 and node number 3, for which enter the displacement on nodes at this node, and at this node we have to arrest all degrees of freedom. click on all degrees of freedom option. So just observe DOFs to be constrained. That means what node has how many DOFs. So I am clicking on all DOFs, which means you can clearly see in the graphical user interface it is arrested along the x direction and along the y direction. Similarly, the node 3 is also arrested along the x direction and y direction. That means we should not have any displacement in both x and y directions at node number 2 and at node number 3. Okay, now in the structural, go to force moment, click on nodes, select the particular node and apply the load as 12 kilonewtons. Okay, so click OK, enter the value as 12 kilonewtons. Okay, we have given the Young's modulus in Newton per mm square. So 12 kilonewtons is converted into 12,000 newtons. Click OK. Just observe the force is in x direction, but in the problem it is given as a downward force. What to do? Now go to delete, structural, forces, nodes, click the selected nodes. This option will delete the earlier load. Click OK. So similar to apply, we have delete option also. Okay. So by using this delete option, we can delete the unwanted data. Again, go to apply, structural, force, on nodes, select the node, click OK. Here it has fx and change it to fy, and in the downward direction, so it should be minus 12,000. Click on OK. Now the problem is perfect. So because of this load, what is the displacement, for which we have to solve the problem. So in the same solution menu, we have an option solve. Click on current LS. Select OK. It will take time based on the system performance, and you have to wait up to a menu which indicates the solution is done appears. Once the solution is done, it means you have given the necessary data to the problem. It does not mean that your analysis is correct. Just it means that the required input parameters are given in order to solve the given component. Okay? Right. Once the solution is done, we can check for the results. The results will be seen in general post processor. The results are seen in general post processor. In the general post processor, go to plot results, go to deformed shape and select the deformed plus undeformed option. Okay, that means this point is transferred to this point because of the applied load, and this is the maximum displacement. Okay, so go to deformed shape and click on deformed plus undeformed option to see how much displacement has done on the graphical user interface. Now again go to contour plot, nodal solution, click on DOF solution and click on displacement vector sum and select OK. This indicates which is the most critical area because of the loading and or where we get the maximum displacement. On the screen you can see that At the second node it is showing blue color, and at the third node it is showing blue color. The blue color is indicating the zero displacement, which means from the problem we have arrested all degrees of freedom at node 2 and at node 3, which means there is no displacement at node 2 and node 3. We have displacement only at node 1. The same is indicated here. The node 2 and node 3 has zero displacement, and the node 1 has the maximum displacement. So plot results option will give you a beautiful colorful images on the screen. But I want to know as a list. Okay, for which go to list results, click on the nodal solution. Again, go to DOF solution, select on displacement vector sum and click on OK. This will give you the list of displacements. For the first node, this is the x directional displacement, and this is the y directional displacement, and this is the resultant displacement. Okay, and at the other nodes the displacements are 0. X directional displacement, y directional displacement and resultant displacement. If the problem has more number of nodes, all the node numbers along with the displacement directions are displayed here. Okay, right. Now after seeing the displacement, we have to go for the calculation of stresses, for which go to read results, select any one option, next set or previous set or the last set, any option is okay, and go to the element table. Define element table, click add and click on the by sequence number, not stress, by sequence number, select LS and enter the value as 1 and enter the value as 1. Click OK. Now close. Okay. After creating the element table, again go to list results, element solution, stresses. In the stresses, check for von Mises stress, click OK. Okay. So these are the stresses. The stress in element 1 is minus 80 newtons, and the stress 2, that is the stress in element 2 is minus 100 newtons. Okay. Now we will check the answers here. The stress in element 2 is minus 100 Newton per mm square. The same result is obtained here. Similarly, again displacements, list results, nodal solution, displacement vector sum, and the displacements are along the x direction minus 0.571 and along the y direction minus 1.952. Minus 0.571 and minus 1.952. Okay, right. Now after calculating the displacements and stresses, we can also calculate the support reactions. Since the second node is fixed support and the third node is fixed support, we have two support reactions, for which go to reaction solution, click on all items, press OK. So at node 2 the reaction is 16 kilonewtons, and at node 3 the reaction is minus 16 kilonewtons. Okay, so we can calculate the displacements, stresses and support reaction. Okay, it is very a straightforward approach. You should not confuse. First select the preferences, give which type of analysis we are going to use. After that preprocessor. In preprocessor also, the each and every step is line by line. Enter the element type. After the element type, give the real constants. However, this problem does not have any real constants. After real constants, enter the material properties. After material properties, enter the area in sections. After the sections, go to modeling, and after the modeling, go to meshing. It follows pure sequence. And this is also a standard procedure. In every problem we follow the same template. Okay. Now after preprocessor, go to processor or solution. Here also go to analysis type and select the static analysis and define loads. The same template. Apply structural displacement. After displacement, enter forces. After given the boundary conditions and the loads, go to solve and solve the problems. So the results are seen in general post processor. The results are seen in general post processor. Plot results will give you a graphical representation of the data on the graphical user interface, whereas the list results will give you the tabulated model of displaying the results. Okay. For the truss problem, we can calculate the displacements, stresses, and also support reactions. After the entire analysis is over, click on finish and close. It is asking for save both geometry and loads, save geometry, loads and solution, save everything I have done and quit no save. I am going to teach you how to save the document in the next videos. So for this, select quit no save and click on OK. Okay. With this, the 2D truss problem